For number 1, I want to find the missing terms in each sequence. The first sequence that's been given to me is an arithmetic sequence, so I know I'm adding something each time as I go from number to number. So from 5 to the next number, I'm adding something, and I know that's the common difference. From this term to this term, I'm adding that same common difference. And from this term to 11, I'm adding that same common difference. So I'm adding the same number each time. That's the pattern for an arithmetic sequence. There's an equation I can write to solve from here. I can say that I have to take 5 and add d 3 times, so 3 d's, to get 11. And then I solve this equation for d. So I'm going to subtract 5 on both sides. That's going to give me 3d is equal to 6. I divide both sides by 3, and I get d is equal to 2. So I know that the thing that I'm adding each time is 2. So I'm adding 2 each time. 5 plus 2 gives me 7. 7 plus 2 gives me 9. 9 plus 2 should give me 11, and it does. For the next sequence that was given to me, I have a geometric sequence, which tells me that I'm multiplying by something each time. So I'm multiplying by something, and I call that something my common ratio, or I let r represent it. As I go from 2 to the next term, I multiply by r. As I go from this term to this term, I'm multiplying by r. As I go from this term to this term, I'm multiplying by r. I can write an equation here to solve 2. Starting with my first term that was given to me, 2. I know I have to multiply that term by r 3 times, so r cubed. If I'm multiplying, it's r cubed instead of 3r. And that's equal to my last number that was given to me, 686. First thing I'm going to do is get rid of this 2 in front of the r cubed because I want to get r by itself. So I'm going to divide by 2. If I did that on the left, I have to do that on the right. Then I end up with r cubed is equal to 343. And then I want to get r by itself on the left-hand side. So I want to undo cubing it, which is taking the cubed root. If I do that on the left, I do that on the right. And I end up with r is equal to 7, I think. From there, I know r is equal to 7, so I'm going to do, every time I go from term to term, I'm going to multiply by 7. 2 times 7 gives me 14. 14 times 7 gives me 98. And then 98 times 7 should give me 686, and it does. And that's how you do number 1. Number 2, I have a sequence that was given to me, 4, 7, 10, 13, 16. I want to know, is this arithmetic or geometric? I want to find what's the pattern as I go from term to term. From 4 to 7, 7 to 10, 10 to 13, 13 to 16, I'm adding 3. That's the pattern. Each time I'm adding 3. So this is arithmetic. This is an arithmetic sequence. The general rule for an arithmetic sequence, I want to start with, so when I write a rule, I'm writing an explicit formula. And that's based on the first term or the term before the first term. The simplest way to write for an arithmetic sequence is using the term before the first term. So this here, this is the first term. I want the term before that. So I'm going to subtract 3 to go backwards, and that's going to tell me my term before my first one is 1. So this is my a sub 0. This was my a sub 1, a sub 2, a sub 3, a sub 4, a sub 5. And for a sub 0, that's I'm going to use in my formula. I have then 1 plus, I take my common difference, which is 3. That's my constant rate of change, and I multiply 3 times the input, which is n. So it's like slope-intercept form. 3 is like my slope, and a sub 0 is like my y-intercept. Then I do what is a sub 15. So for a sub 15, I'm going to do this to the side. I'm plugging in 15 into this formula. So I'm doing a sub 15, which is 1 plus 3 times 15. That's 1 plus 45, which gives me 46. So this should be 46 here. And then I want to know which number term is 334. So 334 is actually what the term is. What is normally my output, so it's my output or my a sub n. I'm going to plug it into my formula, so my formula is a sub n is equal to 1 plus 3n. I'm plugging in for a sub n 334, so I have 334 is equal to 1 plus 3n. I'm going to subtract 1 on both sides because eventually I want to get that n by itself, so I want to get 3n by itself to start. I have 3n is equal to 333. I'm going to divide both sides by 3, and that gives me that n is equal to 111. So it is the 111th term, or just write 111. Don't write the term, the th term. Just write 111 on Edulastic. For number 3, I want to find what's the pattern in this sequence that was given to me. It looks like the numbers are being cut in half. I mean, they are being cut in half or being multiplied by 1/2 each time as I go from number to number. I'm multiplying by 1/2. Since I'm multiplying, I know this is a geometric, and this should say sequence, not series, because I'm not adding them together. This is just a sequence. The general rule for a geometric sequence, I start with the first term because I want the explicit formula. I'm starting with the first term, a sub 1, which is 96. And this time I'm multiplying by something. So I'm not adding, I'm multiplying that first term times the common ratio a certain number of times. So the common ratio here is 1/2. So I'm multiplying by 1/2 n minus 1 times. So n minus 1 should be the exponent. So that's my rule. Then I'm going to find for a sub 7. So I'm going to plug in 7 into this rule. And it's going to give me a sub 7 is equal to 96 times 1/2 to the 7 minus 1 power. That's 1/2 to the 6th power times 96. I know that I have to do 1/2 to the 6th power first, or 1/2 to the 6th power first. So I know the numerator is going to be 1 to the 6th power, which is just 1. The denominator is going to be 2 to the 6th power, which is 64. And then I'm going to multiply that by 96. And I want to just give a decimal answer here, so I'm multiplying 96 times 1/64, or dividing by 64, and I get 1.5. So the answer here is 1.5. And then for the last thing, I want to find what term number is 3/64. So in this case, 3/64 is my output. This is my a sub n, or my output, and I want to find what is the position. What is n? N is the position. So I'm going to use the same formula. So I have a sub n is equal to 96 times 1/2 to the n minus 1 power. And I'm plugging in a sub n is 3/64. And I get when I do that, or what I want to do now is I want to solve for what n is. First thing I'm going to do to get there is I'm going to divide both sides by 96. On the right, I'm going to divide by 96. That's the same as multiplying, since I have a fraction on the left-hand side, by 1/96. And that gives me 3 over, I think I can actually simplify this. 96 divided by 3. Yeah, I can simplify this down to 1 and 32. So I'll end up with 1/32 times 64, which gives me 2048. And on the right-hand side, I have 1/2 raised to the n minus 1 power. I don't know how to get this by itself, so I could solve for it. I don't know how to get to that variable, so I want to rewrite the left-hand side to look like the right-hand side. So I want 1/2 raised to some power is equal to 1/2 raised to n minus 1. And that power that I have to raise 1/2 to, I know I don't have to look at the 1 because 1 to any power is 1. I want to look at what gives 2 to what power gives me 2048. That's 2 to the 11th power. So You just have to play around with it in your calculator until you figure it out. I get this, and then I know that 11 has to be equal to n minus 1 for both sides to be equal to each other. So n minus 1 has to equal 11. I know I'm adding 1 on both sides to solve that n is equal to 12. So it is the 12th term, and I'm just going to put the number 12 in the box. I'm not going to put 12th term, and that's the answer for that one. For number 4, I have a summation notation here. So I'm given a problem. I want to sum the first term to the 26th term. So I want to add the first term to the 26th term. And here's the explicit formula to find each term. That's what that says. First thing I want to do is generate the first 3 terms of the summation. So what I'm going to do is I'm going to get this one here, I'm going to do, I know that n is equal to 1 for the first one, and then I'm just going to plug in 1 into the formula. So 4 minus 2 times 1, which gives me 2. So I know this is 2. For this one, I know n is equal to 2 for the next number. The second term, n is equal to 2, and that tells me I have 4 minus 2 times 2, which gives me 4 minus 4, or 0. So 0 is here. And then the third term, I have n is equal to 3 for the third term. I'm plugging 3 in, that's my position, in for n, so I have 4 minus 2 times 3, which gives me negative 2, for 4 minus 6, which is negative 2. And those are my first 3 terms. For B, how many terms are there total being added together for the summation? I'm going from 1 to 26. That's 26 terms. How many pairs of numbers are there in the summation? Well, I take 26 and I divide by 2. I have 26 total terms. To find how many pairs, I pair them up by dividing by 2. That gives me 13 pairs. Then I want to know what's the sum of each pair. So I know already that, well, what I want to find in the video for arithmetic series, we found that there was a pattern if we paired up the first term and the last term, the second term and the second to last term, the third term and the third to last term. So I just need to find a sub 1 and I need to find a sub 26, and I need to add those together for this because that's the first term and the last term. A sub 1 I already found, it's 2, so I don't need to find that. So I have 2 plus, now I just need to find what a sub 26 is. And I'm just going to plug it into, I'm just going to plug 26 into the formula here, 4 minus 2n. So I do 4 minus 2 times 26. 2 times 26 is 52. I can't do that in my head. 4 minus 52 is negative 48. So I know I'm doing 2 plus negative 48, which gives me negative 46 as the sum of each pair. That's going to be the pattern. Then I could have also used the second term and the second to last term. So n is equal to 2 and n is equal to 25. If I wanted to, I would have gotten the same thing. Find the easiest is to do the first and last. Then I want to find the partial sum. So the partial sum, I know I'm just going to multiply the sum of each pair by the number of pairs that I have. So I'm just going to do 13 times negative 46. I could also, which is 13 times negative 46 is negative 598. Also, the formula that if you didn't do all of B, C, and D, you could just use the formula n over 2. So the partial sum is equal to n over 2 times a sub 1, that's the first term, plus a sub n, which is the last term. And this is the formula you could have used and plugged your numbers in to solve for what the partial sum was. For 5, I have another summation of the first 11 terms of this geometric series. So I'm doing a geometric series here. I know because this is the explicit formula for a geometric sequence. And I want to add the first 3 terms. The first 11 terms. So I know the formula that I'm going to use when I have a finite geometric is S sub n is equal to a sub 1 times 1 minus r to the nth power all over 1 minus r. And I already know what r is. R is the common ratio. So r is equal to 2, and I know the first term already. A sub 1 is equal to 5. Is there anything else I need to know? Yes, I need to know n. N is the number of terms, how many terms I'm adding up, starting with the first one, and that is 11. So I'm plugging now in these numbers into the formula. I have a sub 1 is 5, and multiplying by 1 minus, that's r is 2, raised to the n power. Nope, I'm sorry, n in this case is 11. And then that's all over 1 minus 2. And that's going to give me the sum of the first 11 terms, which is what S sub 11 means. It's the partial sum. I'm adding the first 11 terms. And then from there, I just simplify. So 2 to the 11th power is 2048. So I have 5 times 1 minus 2048 all over negative 1. That's going to give me 5 divided by negative 1 is negative 5 times, in parentheses, I have negative 2047. And when I multiply these together, 2047, negative times negative 5, I get positive 10,235. So my answer is 10,235. For number 6, I've been given a summation of the first 4 terms, so I'm going from term 1 to term 4, adding those together, and I've been given this explicit formula with 2 variables. K is actually the position, so the variable that I'm going to have that's unknown for each term is x, and that's why I want to solve for x. So I want to do the same thing as always. I only have 4 terms here, so I can find each term. I'm going to do the first term. I'm just going to write it like this. I'm going to do the first term. I know that's when k is equal to 1. K is the position. Whatever variable it says down here is the variable for position in the list. And so instead of n is equal to 1, I have k is equal to 1. When k is equal to 1, I will plug that into this formula, and I'll get x plus 3. For the second term, I know I have k is equal to 2. When I plug that into this formula, I'll have 2 times x plus 3. So 2x plus 3. For the third term, I know that k is equal to, so k is equal to 3, I'll have 3x plus 3. And then for the fourth term, I'll have k is equal to 4, which means 4x plus 3 is my term. These are my actual terms. I want to add these up. And when I add them up, the summation is 562. So the sum of those terms is 562. So what I'm writing here is, and I'm going to combine my like terms. So I have x plus 2x plus 3x plus 4x. That gives me x plus 2x is 3x, 3x plus 3x is 6x, 6x plus 4x is 10x. So I have 10x plus I have 3, 6, 9, 12. So I have plus 12, and that gives me 562. I'm going to now subtract 12 on both sides. That's going to give me 10x is equal to 550. I'm going to divide both sides by 10, and that's going to tell me that I have x is equal to 55. So I solved for x, it's 55. Done. And number 7, the last one, I have 200 plus 100 plus 50 plus 25. This is a series since I'm adding the numbers together. I have a dot, 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 so that means it's an infinite series. Well, let me write this on the side. Oops. It's infinite So that's the answer to the first one. And I know that it converges since my numbers are going down each time. That is what makes it clear, but what I'm actually doing as I go from term to term is I'm multiplying by 1/2. 1/2 is less than 1, so because the absolute value of r is less than 1, I know this converges. So it's infinite, it converges, and that means I can find the sum. And the sum is I'm going to use the formula s is equal to a over 1 minus r. So a sub 1, over 1 minus r. I have my a sub 1, it's 200, that's my a sub 1. I have my r, which is 1/2, so a sub 1 is equal to 200, and r is equal to 1/2, and then I just plug those numbers in here. So I'm going to have 200 so the sum is equal to 200 over 1 minus 1/2. That's 200 divided by 1/2. And I can write that like this. And rewrite 200 as a fraction. Change this to multiplication and this to its reciprocal. And I'll get 400 is the answer. So the answer is 400.